Okay guys, today's lesson is going to be on angle sums, so interior and exterior angle sums of polygons. Now some of this you actually already know and should be a review. For instance, when we talk about interior angle sums, we're talking about the angles on the inside of a polygon. So for a triangle has three interior angles, these three angles. And these three angles you should already know should add up to 180. So the sum of a triangle's interior angles is 180 degrees. This is something you already know. Another thing you already know is a quadrilateral. So a quadrilateral is any four-sided figure. It does not have to be a square or rectangle. Any four-sided figure will have four angles that are inside the figure, and those four angles should add up to 360 degrees. This should be a review. These are interior angles. Exterior angles are the angles that are on the outside of those three interior angles. Now they're not the reflex angle. They're not this angle that goes all the way back around, would be 200 something degrees. The exterior angle is basically a supplement of the interior angle. If you could imagine a line coming out here, this right here would be the exterior angle. So it's the supplements to those other angles. And we'll talk more about exterior angles in a little bit. First off, I want to focus on the interior angles and how to figure out the sums of interior angles of polygons other than triangles and quadrilaterals with 5 sides or 4 sides or more. So before we go on, I want to look at this quadrilateral right here. If I were to divide a quadrilateral into two, connecting two of these vertices, it creates two triangles basically. So here's one triangle and here's the other triangle. The reason that the angle sum of a quadrilateral is 360 degrees is because if I were to add up these three angles of the triangle, then we would have 180 degrees. And if I would add up these angles of this other triangle, I would have another 180 degrees in total. So basically, within a quadrilateral, we have two triangles. Those two triangles each have 180 degrees in their angles. So 180 plus 180 would give us 360 degrees in the entire quadrilateral. We can kind of use this method to figure out angle sums of other shapes. So for instance, a pentagon, which has 5 sides. There's a pentagon. A 5-sided figure, what you do to figure out how many angles are, what the sum of the angles are, pick a vertex. I'm going to use this vertex right here, and connect that one vertex to all the other vertices except the two that are side by side. So basically, I can connect it to two other vertices. I can't connect it to this one or this one because that would just be one of the sides of the pentagon. I want to create sections. I want to create triangles. And what happens when I do that is I create 3 triangles. Each of these triangles has an angle sum of 180 degrees. So when I combine these angles for each of these triangles, I have a sum of 180 degrees. This smaller triangle has a sum of 180 degrees. So a pentagon, or a 5-sided figure, has an angle sum. The interior angle sum is 180 times 3, because you create 3 interior triangles, so each of those triangles is 180 degrees, and that ends up being 540 degrees. So the interior angle sum of a pentagon is 540 degrees. Alright, so let's take another shape. Let's take a hexagon. And we'll look at the interior angle sum. So we'll draw a hexagon. Okay, there's a hexagon. With a hexagon has 6 sides, 6 vertices. Pick one of these vertices. I'm going to pick this one right here to start with, and connect it to all the other vertices except the 2 that are adjacent to it. So I'm going to connect it first to this one, then to this one, then to this one, and see how many triangles you make. Well, I make a triangle here, that's 180. I make a triangle here, I make another one here and here. So I have 4 triangles. So for a hexagon, I have 4 triangles that are created on the inside of that, which means that each of those triangles has 180 degrees. So the interior angle sum of this hexagon would be 180 times 4. So it'd be whatever 180 times 4 is. This ends up being 720 degrees. So if I have a hexagon or any 6-sided figure, 720 degrees is the sum of the interior angles. Now, there is a formula that we can use. If we look at what we just talked about, and we make a chart, and you should write this down. So for the polygon, however many sides it has, so we did a 3-sided and a 4-sided figure first, triangles and quadrilaterals. The number of triangles created kind of helps tell you how to get the interior angle sum, so you don't have to memorize them all. Well, for a triangle, obviously there's just one triangle in that triangle. A quadrilateral, there are 2 triangles. A 5-sided figure, we said, has 3 triangles. A 6-sided figure we just did has 4 triangles. So the interior angle sum of each of these would be the number of triangles times 180. So a 5-sided figure has 3 triangles on the inside. So the interior angle sum was 3 times 180. For the hexagon, it was 4 times 180. And we could continue doing this for several shapes, and we don't have to keep drawing them out. I should know, I can tell by there's a pattern developing here. If I had a 7-sided figure, we should be able to tell how many triangles, because we can see that we're increasing the number of triangles by 1 each time. So the 7-sided figure should have 5 triangles on the inside of it. So for the interior angles, I would do 5 times 180. And then as these numbers get bigger, we can start using a calculator to do some of these. That ends up being degrees for the interior angle sum of a 7-sided figure. So if you notice, the number of triangles is always 2 less than the number of sides. So if you understand that the number of triangles created is always 2 less than the number of sides, you'll know how to get the interior angle sum of even larger numbers. So for instance, if I said, we'll skip some of these. Let's say I wanted to know a 14-sided figure, what the interior angle sum, if I were to add up the sum of all the interior angles of a large 14-sided figure. Well, the pattern holds that however many triangles we would be able to create on the inside there would be 2 less than 14, so I would have 12 triangles on the inside. So my interior angle sum, each of those triangles is 180 degrees. So my interior angle sum of all those angles is 12 times 180. And that's 2,160 degrees. So this can help you find missing angles of larger figures. You probably won't have a picture of a 14-sided figure, but certainly pentagons, hexagons, octagons, and this will help you find those missing angles if you know what the angles are supposed to add up to. Just like in a triangle, when you're missing one angle, if I know one's 30 degrees and one's 50 degrees, I can figure out the remaining angle is 100 because I know that they're supposed to add up to 180. Now you can do that with other shapes like hexagons and octagons. You just need to know that the sum, instead of being 180, might be 720 for a hexagon. So there is a formula you can use, and this is the formula that you need to know and write down. The interior angle sum formula is n minus 2. N is the number of sides. So you take the number of sides, subtract 2, just like we did for all of these, and then you multiply that by 180. So that's the formula for finding the interior angle sum of any polygon, regardless of how many sides we have. Take the number of sides, subtract 2, and multiply it by 180. Okay, so let's talk real quickly about exterior angles. And we're just going to do it with a triangle. So let's say these are my interior angles of a triangle. Well, we said the exterior angles are basically supplements of that. If you could imagine a little line extending out here. The exterior angle would be the supplement of each of those interior angles. So these exterior angles, for the 60-degree angle, the exterior angle is 120 degrees. For the 70-degree angle, the exterior angle is 110. And for the 50-degree angle, the exterior angle is 130. Oops, and I miswrote that. So if I wanted to know the exterior angle sum, I would add up those exterior angles. 120 plus 110 plus 130 gives me 360 degrees. So the exterior angle sum of this triangle is 360 degrees. And in fact, the exterior angle sum of any shape is always 360 degrees, no matter what shape. So all polygons have an exterior angle sum of 360 degrees. If we look at a rectangle, these are all 90-degree angles for the interior angles, but the exterior angles would also all be right angles. And it doesn't matter which direction you draw your lines going out, it's still a supplementary angle. The exterior angles are still all 90 degrees here. So we still have an exterior angle sum of 360 degrees. So regardless of what shape you have, whether it's a hexagon, a pentagon, an octagon, the sum of all the exterior angles ends up being 360 degrees. And an important fact to know and to have in your notes is that interior angles and exterior angles are supplementary. That means they add up to 180 degrees. So an interior angle and its exterior angle always add up to 180 degrees. So that's kind of the basis of what interior angles are and how to get the sum for a polygon and what exterior angles are.